Welcome back to the VMware View Administration training course. This time we're going to talk about how to configure your virtual desktops. In this lesson, I'll go over some of the best practices for creating your parent VM image. I'll talk about the types of View desktops that you can create and when you would want to use each one. I'll go over some of the configuration options you have when creating your desktop pools. I'll help you to understand what the link clones really are and the different pieces that make them up. And then I'll talk about the options you have for sizing your desktop pool. And we'll finish by doing a demonstration and walking you through the creation of a couple different types of pools. So let's get started. When creating the parent VM that'll be the basis of all your virtual desktops, it's important to spend some time doing some best practices and make sure that that desktop is as best as it can be. The goal ultimately is to reduce the amount of CPU, RAM, disk, and network load that virtual machine will place upon the host. Remember, this image will be recreated multiple times, and if you don't clean it up properly, any mistakes will be repeated multiple times across all of your hosts. So first, make sure you remove or disable any unnecessary items. There's a lot of services that Windows XP, Vista, and 7 include that really aren't necessary for most users, especially in a business environment. There's scheduled tasks that are set to run on a regular basis. Often those tasks don't need to run, especially when we consider the fact that we're going to refresh a lot of our pools and start them off at a base image again every day. Indexing is one service I make sure to completely disable. It causes a lot of extra disk I/O that isn't necessary for most users. So by removing or disabling these items, you'll free up a lot of resources inside that virtual machine. Go with the least common denominator approach to this desktop. Think of all the different types of users that you'll have to support within your View infrastructure. Add in the least amount of stuff that you'll need in order to support all these different types. For example, none of your user types are probably going to need to have the different games that Windows comes built in with, so make sure to remove those completely. By eliminating the visual effects within Windows, you reduce the amount of changes that have to occur on the screen, and the amount of work that needs to be done to compose those images. This will reduce bandwidth and CPU cycles on the virtual desktop, both of which will greatly improve the user experience. As a general rule, if a setting gives you a configure for best performance option, go with that one. A corporate desktop is designed for performance, not for prettiness. At this point, it's fairly well documented that aligning your partitions properly is an important thing for improving your disk I/O. If you're not familiar with this issue with x86 systems, I encourage you to search the web. There's lots of great documentation out there for it. I'll link to a specific KB article that VMware has for this particular issue. What this will require with a Windows XP image is booting into some sort of pre-execution environment before loading XP onto the disk. Windows 7 gives you the advantage that you don't actually have to do this, because it will properly align the partition during installation. Searching the web will give you many different guides for optimizing the image of a Windows XP or Windows 7 desktop. At the end of this video, I'll provide you with a URL to one of VMware's documents on how to optimize Windows 7 for View. And most importantly, whatever changes you make to your desktop, make sure you test it very thoroughly. This will be the basis for all of your virtual desktops, so you got to make sure that it's going to work in all cases. And the best time to do that is before you deploy any pools. So what are the different types of desktops that we can deploy? First of all, you can deploy individual desktops. This is simply a pool of a single desktop assigned to a very specific user. This could be useful for very specific use cases. Take for example a CEO. No one else really is going to use a desktop the way the CEO is. So you can set up a very specific desktop just for him or her and publish it so that only they can see it. View is really strongest when you talk about the pool concept, which is a logical grouping of a bunch of virtual machines. These virtual machines may be the same as one another, or they may be disparate, but they're all accessed as a single entity. Within a floating pool, a user may access any desktop at any time, and the desktop a user is assigned today may not be the same desktop they are assigned tomorrow. In this type of pool, the desktops are generally equal and configured identically from one another. In a dedicated pool, A user is assigned a desktop the first time they access the pool. Once they've been assigned to that desktop, that assignment stays forever, and they'll continue to access that same desktop every time they connect to the pool. An automated pool is a pool that is completely created and managed by VMware View. Combining an automated pool with a floating pool presents the best case scenario for a View infrastructure, where users can access any desktop because they're all identical, and they're all created, deleted, and managed by View automatically. In a manual pool, the administrator must create the virtual machines or physical desktops manually, and then add them one at a time into the pool. This is generally used when you want to have a pool of disparate virtual machine configurations, or a pool which is made up of physical workstations, or blade PCs. Manual pools are usually tied with dedicated pools, so that one user will always get the same desktop. Linked clone pools are based on the Composer functionality, and their main advantage is the ability to create them quickly, update them quickly and as an entire unit, and save a lot of disk space by having all the different VMs point back to a single base image, rather than having a disk completely of their own. A full clone pool is a pool in which each virtual machine is completely independent of all the others. The main time you would ever want to use a full clone pool is when you have users that need to modify the OS itself and maintain those changes from one session to the next. If you were to place those users into a linked clone pool, the Delta files that represent the linked clones would start to grow out of hand and would become very unmanageable and difficult to deal with. So when creating a pool, you have three decisions to make. You can create it as a floating or dedicated, plus an automated or manual, plus linked clone or full clone. The different combinations represent different types of use cases, but there are special combinations that show up more often than others. When we do our demonstration, we'll demo three different combinations. The first will be a floating, automated, linked clone pool. The second one will be a dedicated, automated, linked clone pool. And the third will be a dedicated, manual, full clone pool. Finally, you can create a terminal services pool, which makes View a front end to a terminal services farm. This isn't a great use case, but it does provide a single interface for all users if you have some using virtual desktops and some using terminal services. Once you decide what type of pool you want, you have many other options still to choose for configuring your desktop pool. First, you'll need to identify an identification for the pool. This is a unique identifier that only administrators would see. Then you need to define a name for the pool itself. This is the name that the end users will see when connecting to your View infrastructure. You can also provide a description so it's easier to tell what the pool is used for. You'll then need to define a naming standard for the virtual machines that are in the pool. This is limited to 13 characters and is based on a sequential numbering scheme. The pool settings are a big group of different options that define how the pool behaves. Everything from whether a VM should be powered on or off when not in use, to what happens to a desktop when a user logs off. It includes performance decisions, like how much to throttle Adobe Flash and which default protocol should be used. Depending on the type of pool you create, you have several disk options that you can choose from. You can create persistent disks for maintaining user data from one session to the next, even though they may not be connecting to the same desktop. There's the disposable disk, which contains the Windows page file and other temporary files that can easily be thrown away after a user logs off. You can also define what data stores the VMs in the pool will exist on, and you can even divide up the different disks onto different data stores, which allows for tiering of your disks, so that the disks that need a high I/O can be placed on higher end storage. This can be a huge performance boost. You also get to define the size of the pool in both a minimum and a maximum configuration. You will also have the option to define how many spare desktops are available in order to provide users the best connection experience as possible. When creating a non-composer-based full clone pool, you'll need to choose a virtual machine template to base the virtual desktops on. When creating a composer-based linked clone pool, you'll need to choose a parent VM an associated snapshot to base the virtual desktops on. You'll also need to choose the cluster, resource pool, and virtual machine folder that you want the VMs to be placed into. It's important to pre-create these before creating the virtual desktop pool, because you have no option to create them while inside of the wizard. You can also identify connection server restrictions, or tags as they're sometimes called. By identifying tags on the virtual desktop pools, you are limiting access to the pool to connection servers that have the same tag. This can be useful when wanting to prevent certain desktop pools from being accessed from the security server and its associated connection server, or to limit certain types of users, like bring your own PC type users, that may be isolated to a separate network segment. When creating full clone pools, you'll need to identify a vCenter guest customization specification to use to customize each desktop once it's deployed. When creating linked clone pools, you'll be able to either select sysprep or use VMware's quick prep process, which performs a lot of the same functions as sysprep, but does it in a much quicker fashion to get the desktop up and available as soon as possible. The final step of the process is to actually entitle users to the pool. This provides them the access they need in order to connect to a desktop. So let's talk a little bit more about composer-based linked clones. As stated before, you'll need to start with a parent VM that has at least one snapshot. Using snapshots makes it easy to keep track of your composer-based images. When performing updates, you simply update the VM, shut it back down, and create a new snapshot. You can then go into the View Administrator and repoint all of your desktops to use this new snapshot. So the first thing that happens when creating a linked clone is that there must be a replica. The replica is a special type of virtual machine that is a thin provisioned full clone of the parent VM at the identified snapshot. This is a protected VM within vCenter, so you can't do anything with it directly. This is ultimately what the individual virtual desktops will point to as their base disk. Replica is a VM of its own. It's a thin provisioned full clone of the parent VM at that particular snapshot that was identified. When creating your pool, you have the option to identify which data store the replica exists on. This provides you the capability of creating more than one replica to base your images on. If you don't identify a specific data store, then every data store that's being used in this pool will have a copy of the replica. The advantage of putting the replica on a single data store for the entire pool is to put it on higher end disk. If you put it on an extremely high I/O disk, like an array of SSD drives, you'll get ultimate performance out of your desktop pool. Each VM then is actually comprised of the Delta disk, which tracks all the changes made to the system drive, and an optional disposable disk, which contains the data that can be thrown away each time the user logs off. Quick Prep is the recommended alternative to sysprep when creating linked clones. This will perform the image customization that sysprep normally would, but skips a lot of the steps that are unnecessary. Primarily, Quick Prep is going to name the virtual machine, add it to the domain, and change the SID, thereby making it a unique entity within the Active Directory domain. You also get the option to define your storage overcommitment on each data store. None will not allow any storage overcommitment, so if you have a parent image that is 20 gig in size, each individual virtual desktop will be reserved 20 gig on the data store that is placed, even if that Delta disk only grows to 2 gigabytes. Conservative, moderate, and aggressive settings determine how much overcommitment is allowed. With an aggressive setting on a data store, you will place a lot more virtual desktops onto that data store. You would use this setting if the virtual desktops won't grow much over time, or will be refreshed on a regular basis. Finally, using linked clones gives us some special operations that we can perform on the virtual machines and the pools. Refresh will throw away all changes made to the virtual desktop and take it back to the known good parent VM. This is useful for keeping disk utilization down to minimum. It also makes an easy way to clean up any issues the user may have created on their desktop. Recompose is the functionality that we use in order to update an entire pool very quickly to the new snapshot on the parent VM. A rebalance operation will level out our disk utilization across all of the data stores that the pool is going to use. This ensures the best balance of disk utilization and disk I/O to each LUN. We'll cover these three operations in more detail when we talk about how we maintain our virtual desktop pools. Let's talk a little bit more about the persistent disk. As stated before, it preserves the user's data during these composer operations. Without the persistent disk, all the user's profile information would be wiped out when we wiped out the system drive. By redirecting this information to a persistent disk, that information is not lost, and the user can have a consistent experience from one session to the next, even though we're cleaning up the image every time they log off. It is possible to detach this persistent disk from the desktop the user has been assigned to. This can be useful when migrating a user to a new pool, or when a user is no longer entitled to the pool, but we still want to maintain their user data for forensic or backup purposes. If we detach the disk from the View desktop and then reattach it to another desktop, you need to make sure that both desktops are using the same operating system. Otherwise, you'll confuse the new operating system because it won't be able to properly read the profile. The disposable disk, on the other hand, can be used to slow the growth of the linked clone, because many of the changes that go into the delta disk of a linked clone are files that can easily be thrown away after the user is done with the desktop. These include the paging file and temporary files that the OS would create. When the VM is powered off, these files can easily be thrown away and a new disposable disk created in its place. No matter where you store the persistent or replica disks, the disposable data disk is always stored on the same data store as the OS system disk. Defining the size of the pool is a very important exercise, but one that may take some trial and error. So let me provide you some guidance. First of all, figure out what the minimum number of desktops needed are. Just as it sounds, this is the least number of desktops that will ever be deployed into the pool. If enough VMs get deleted to put the number of desktops in the pool under this number, then View will deploy new virtual machines to replace those and bring up the number of desktops in the pool to the minimum number. While View can deploy desktops pretty quickly, having an end user have to sit and wait through the whole deployment process can definitely give your View infrastructure a very bad name. Next, you can define the number of spare powered-on desktops that will be available. This also goes to making sure that end users will have a desktop ready and waiting for them when they try to connect. This number can be less than the minimum, and will always ensure this number of desktops will be available above what's currently in use. The maximum number of desktops indicates the ceiling size for the pool. I've run into several situations where the maximum number of desktops actually needs to be greater than the number of licenses you own. View is licensed per concurrent user, not by the number of desktops that are deployed. So using maximum may not always be the best way to police your licensing of View. One example is if you create a pool for a school computer lab. You may have 25 desks there, and that's all the more that will ever need to be in the pool. But if you set the maximum to 25, and 25 students sit down during a class, they'll all log off at the exact same time. So you'll have 25 desktops in the pool that all need to be refreshed at once. If the next class comes in 5 minutes later and sits down, they expect to have a desktop ready for them. But if the previous 25 are still refreshing and you set your maximum to 25 desktops, that second class may not have a desktop available to them immediately. One of the pool settings that you'll need to define while creating the pool is the pool power policy. This policy will define what power state unused desktops are in. How many VMs end up being controlled by this policy depends on the intermix of your minimum, maximum, and spare desktops. Let's look at an example. So let's say we have a minimum of 10 desktops, a maximum of 100, and a spare of 5, with a power policy that will suspend any virtual machines that are not currently needed. When no users are connected, you'll have 10 virtual machines that are deployed, 5 of which will be powered on, and the remaining 5 will be suspended. So the number deployed is determined by the minimum, and the 5 that are powered on are determined by our spare setting. When we get 5 users logged into the pool, we'll have 10 desktops deployed and 10 VMs that are powered on. So at this point, 5 desktops have been assigned to the users. View then powers on the other 5 to meet our spare setting. Once the 6th user is logged in, they'll get the 6th desktop assigned to them, which then puts us at 4 spare desktops available. So View then deploys a new desktop, taking us up to 11 desktops deployed, with 11 of them powered on. On the opposite end of the spectrum, if 97 users are connected, 97 desktops will have been assigned. But we'll still only have 100 deployed and powered on, because our maximum is 100. So if 3 more people connect, we'll have used up every single desktop in the pool. And if a 101st person tries to connect, they'll get access denied because there will be no desktops available for them to connect to. Okay, now I'm going to show you what this actually looks like. We'll explain all the options in a little bit more detail as we go through, so they'll make a lot more sense. For this pool, we'll use linked clones to take best advantage of space savings and ease of updating capabilities of View Composer. So here's my View Administrator, and you can see we're currently in the Inventory Pools section. In this particular area, you would normally see the list of pools that have been created. I currently have no pools created right now, so this will be our first one. You can also see there's the ability to filter, where we can choose which fields to filter on. We also have the ability to show only specific folders. So let's go ahead and add our first pool. Our first choice is Automated, Manual, or Terminal Services Pool. You can see as I choose the different options, in the lower right-hand corner there's a Supported Features section that will change. This gives us an indication of what features will be available to us as we change between the different options. You'll see this continue throughout the steps of this wizard. We'll go with an automated pool and click Next. Next, we get to choose how the users are assigned. We can choose to have them dedicated, meaning a user will get the same desktop every time they log in. We can also choose a floating pool, in which a user will randomly be assigned a desktop each time they log in, and they may not get the same one each time. For this pool, we're going to go with floating, so we'll click Next. Now we get to choose which vCenter server we're going to use, and whether or not it'll be a full or a View Composer-based linked clone pool. For this one, we're going to choose Composer-based. And our only vCenter option is VC01, which does have View Composer enabled. So now we can click Next. Now we start our settings for the pool itself. The first field is the ID field. This is a unique name that will be used to identify the pool internally within View and the View Administrator. We'll use the name Administrative Pool. Notice when I put a space into the ID, the text box gets outlined by red. That's because spaces are not allowed in the ID field. So let's replace that space with an underscore. And now you'll see the red box has disappeared. Next, we move on to the display name. This is the name that will actually be displayed to the end users. So we'll use Administrative Pool here, but this time we'll leave the space in. Next, we have the option of choosing a folder. We currently only have 2 folders available here, so we'll go with the default of the root folder. Finally, we can define a description for this pool, which will only be available for the View administrators to see. Now that everything looks good, we can click Next and move on. In the pool settings screen, we've got a lot to cover here. First up is the state of the pool, which can either be enabled or disabled. This is the master switch for the pool and determines whether it will be available for users to use and whether or not provisioning will occur. Generally, at this point, you'll want to use enabled. Next, we can choose our connection server restrictions. We can either choose to have no restrictions, meaning that every connection server has access to this pool, or we can restrict it to certain tags. By selecting External, we limit access to this pool to only connection servers that have the external tag assigned. By selecting Internal, we restrict access to this pool to only connection servers that have the internal tag assigned to them. If we assign the internal tag to connection servers that do not have a security server pair, this pool will only be available internally and cannot be accessed through a security server. Since we don't expect our administrative staff to work from home or from other locations other than their office desk, we'll go ahead and restrict it to internal. Next, let's choose our remote desktop power policy. This setting determines what power state an unused virtual desktop will be placed into. Take no power action means that View will take no action to power it on or power it off when it is unused. When Ensured Desktops are always powered on is selected, View will automatically power on any VMs that get powered off by an end user or a vCenter operation. Setting this policy to Suspend will suspend any virtual machines that are not in use. Setting the policy to power off will power off a virtual machine that is not in use. For our scenario, the administrative staff is pretty consistent and there'll be very little variability within the pool. So we'll go with Ensure Desktops are always powered on. This provides the best performance when users try to log in, because View doesn't have to power on any desktops in order to maintain the size of the pool. Remember, what you select for your power policy for any desktop pool will be closely tied to your minimum, maximum, and spare desktop provisioning settings. Those particular settings we'll get to in a couple screens. One thing I want to make note of while we're here is these little question marks. When clicking on the question mark, a little information window will pop up, giving you more information about that particular setting or object within the View Administrator. These are very useful and can provide you context-sensitive help. Our next setting is the automatically log off after disconnect. Here our options are immediate, which means that as soon as a user disconnects from their session, they will immediately be logged off that desktop. This disconnect could be an administrative action, a drop of network connectivity, or the user closing the View window. If we want a user to never automatically log off when their session disconnects, we can choose the Never option, which will always leave the user logged in unless they explicitly log off the desktop. The option I see most often used is the After, which gives the admin the ability to define how many minutes after a disconnect an automatic logoff will occur. In this default setting, the logoff would occur after 120 minutes, or 2 hours. This is a fairly reasonable setting, because it gives the user enough time to reconnect manually if a network drop occurred. I've seen automatic logoffs be set anywhere from immediate to 8 hours, depending on the use case. Next, we'll look at the Allow users to reset their desktops, which is a simple yes or no option. This gives the user the ability to do a hard reset of their desktop from within the View client. The default is usually fine here. Next, the Allow multiple sessions per user setting is again a simple yes or no option. This setting defines whether a user can connect to multiple View desktops within the same pool. This would be governed based on the device that they're connecting from. So if a user connects to a desktop from their workstation at work, and then goes to a conference room and connects from a thin client in the conference room, the user would then have 2 sessions open within View to the same pool. This is not what we usually want, so we'll go with a no answer here as well. Next is the Delete or Refresh Desktop on Logoff. This setting will define what happens to a desktop when the user logs off of it. Never indicates that the virtual machine will stay at the same state the user left it in when they logged off. Setting it to delete immediately will do just that. View will delete the virtual machine as soon as the user is logged off. This could cause a new virtual machine to be deployed if this causes the pool to dip below the minimum or spare capacity we define in the provisioning settings. Refresh immediately will tell Composer to refresh this desktop as soon as the user logs off, which leaves a clean desktop image ready for the next user who connects to this desktop. We'll go with refresh immediately because we want each user to connect to a clean image each time, and refreshing the desktop is a lot less resource intensive than deleting it. We'll talk about refresh more in the lesson on maintaining desktop pools. Next, we can define what the default display protocol is for this pool. And our two choices are RDP or PC over IP. We'll go with PC over IP as our default, and only use RDP if we can't use PC over IP for some reason. The next setting, Allow users to choose protocol, defines whether the user has the ability to override our default. By selecting yes, the user will have the ability, within the View client, to choose RDP as their connection setting. This particular option is not very obvious in the View client, but we'll go ahead and leave it enabled so that we can tell users to change it if we feel the need to. The max number of monitors and max resolution of one monitor work together to define what our maximum monitor setup will be for our View clients. These two settings will define the video RAM size of the virtual machines deployed into this pool. The final pool settings are used to define Adobe Flash within our remote sessions. We can first choose the quality and whether or not Flash will be throttled. These settings can be useful when dealing with WAN connections that have low latency or low bandwidth. Since most of our administrative users will be on the LAN, we'll go ahead and leave these disabled. And we'll move on to the next section. Here we can define our disposable disk. The most important thing to remember is that our disposable disk must be big enough to contain our Windows page file. For this pool, we'll leave disposable file redirection enabled, since the pool will be highly dynamic and will need to be refreshed often. By using the disposable file redirection, View can more quickly erase the changes that the user made and refresh the desktop quicker. Go ahead and click Next to move on to our provisioning settings. Here we have the option to enable provisioning. This will determine whether or not the pool will be deployed after we finish this wizard. We have no concerns with this, so we'll leave it enabled here. Stop provisioning on error can be a dual-edged sword. If we leave this enabled, and View encounters an error while provisioning a desktop, if that error happens to be isolated to that single virtual machine, we've now stopped provisioning for an entire pool because of one desktop's mistake. If the pool is not watched closely, you as an administrator may not know that the provisioning has been disabled until you get calls from end users saying they cannot connect to a desktop. Alternatively, if we disable this option, and View runs into an error while provisioning multiple desktops, we may end up with a lot of extra desktops that we don't actually need. This can put a strain on our resources on our hosts, our DHCP scope, and our storage. When first creating a pool, I usually leave this enabled, so if we do run into any errors, provisioning will be disabled and we can deal with it quickly before it gets out of hand. Once this pool is in production and running smoothly, we may want to come back in here and uncheck this option. Next, we can define the naming of the virtual machine. We can either specify names manually or use a naming pattern. When specifying names manually, we can come in and enter which names we want to create. So here we get a big text box where we can enter the names that we want the pool to use, one per line. We also have the option of adding a username to the end of each desktop. This can be used when creating a dedicated pool where we want to predefine which users get which desktops. For this pool, we don't want to enter these desktop names, so we'll cancel out of this. For this pool, we want to use a naming pattern, which we'll define here. We'll give each VM the name of admin_DT. If we left the naming pattern here, we would get desktops that would be named admin_DT1, admin_DT2, and so forth. But we want to put our number after the word admin and before the DT. To do that, we simply put an N inside the curly braces. This tells View we want a sequential number to be placed at that position within the name. Now our desktops will be named admin1dt, admin2dt, and so forth. But we actually want it to be admin01dt, admin02dt, and so forth. In order to do that, we simply follow the end by a colon, the word fixed, the equal sign, and the number of digits we want that number to contain. This indicates to View that no matter what number gets put in there, it should always have 2 digits. So our numbers will go 01, 02, 03, all the way to 10, and up through 99. We need to make sure that this number reflects the sizing of our pool, which we'll touch on next. We discussed pool sizing earlier in this lesson. So here we could actually define our maximum, our spares, and our minimum number of desktops. At Home Royal Furniture, they have 5 different administrative users. To account for refreshes on logoff, and to assure users will always have a desktop available to them, we're going to go with double the number of VMs as we have users. So here we'll enter 10. Since we only have 5 users, and the likelihood of all 5 of those users needing a second desktop immediately is pretty slim, we'll keep the number of spare desktops low, and go with a number of 2 here. Since we set our power policy to always on, these 2 desktops will always be powered on and available for users to connect to. Next we can choose whether to provision desktops on demand, or we can provision all desktops up front. By provisioning all desktops up front, our pool would automatically always have 10 desktops in it. Since we'll rarely have 10 users connected at one time, we'll go ahead and select Provision Desktops on Demand, which gives us the option to now define our minimum number of desktops. In this scenario, we'll know on a daily basis we'll usually have 5 users connected, so let's go ahead and make that our minimum. This ensures that on a typical day, every user will have a desktop ready and waiting for them. Now that we got all of our provisioning settings set up, we can move on to the next step. Now we get to set up how the pool will be deployed within vCenter. We'll start by defining our default image. We must first choose our parent VM. Right now we only have one parent VM, so our choice is pretty simple. Once we've selected the parent VM, we choose which snapshot this pool will be based upon. We do have the option at this point to define whether or not this pool will be available through local mode. We don't need this option for our administrative staff, so we will not check this. Now we choose which folder we want the desktops to go into within vCenter. And we'll choose vDesktops. Next, we choose which host or cluster it'll be in. Again, our choice is easy, as we only have one cluster to choose from. Notice that vSphere mode is automatically selected for this cluster, which means we no longer have the option of placing ESX 3.5 hosts into this cluster. Next, we choose a resource pool for the desktops to exist within. We haven't created any new explicit resource pools within vCenter, so our only option is the cluster itself. So we'll select that. Finally, we choose what data stores we want all of our disks to end up on. Here we see we have 2 local data stores, one for each of our hosts. We have an iSCSI, and we have an NFS share to choose from. We could choose one or more of these. When selecting these data stores, we have the option of choosing which storage overcommitment we want to identify for this particular data store. In our case, we'll stick with conservative. We can also choose whether or not we want to put our replica disks onto separate data stores. By checking this checkbox, we'll first get a warning that tells us that we need to be careful about where we place these replica disks. It is recommended that if we separate them, we put our replica onto a higher tier of storage, and that we should avoid any single points of failure. Clicking OK, we'll find that we have a new column to choose from, the Use For column, in which we can choose whether this particular data store is used for linked clones or for replica disks. We'll choose to put our replica disks in our iSCSI storage. Not because it'll perform any better, but simply to show the separation of the two different disks. Now that we've set up our vCenter placement, we can click Next. Now we're able to define how the different virtual machines are going to be customized. First of all, we can choose our domain. In this scenario, we only have a single domain, so there's not much choice there. But you can see that it is using the View Service account to add to the domain. Next, we can choose which AD container the desktops will be placed into. So we'll click Browse and navigate down our AD tree to choose our OU equal vDesktops. For the actual customization process, we can choose whether to use traditional sysprep or use the new QuickPrep that Composer provides to us. When using sysprep, we can choose from one of the vCenter customization specifications. QuickPrep is definitely the quicker of the two options, so we'll stick with that option. When choosing QuickPrep, we can provide a power off script and a post synchronization script to be run on the virtual desktops. These scripts are run from the context of the virtual desktop itself, so it's recommended to either place these scripts on a network share that they can access or inside of the image itself. We have neither of these to define, so we'll go ahead and click Next, where we're given a summary of all of the options that we've chosen for this pool. Once we've reviewed these settings and determined that everything looks okay, we click Finish. Now our pool has been created and should be deploying. Let's switch over to the vCenter console and take a look. Looking at our vSphere client, you can see a new folder has been created, and a clone of our virtual desktop parent image has begun. This clone is actually the replica that's going to exist on our iSCSI storage. This is the replica here. Switching over to our VMs and templates view, we can see that an administrative pool folder has been created within the vDesktops folder. This is where all of our virtual desktops will end up in once they're created. But for now, we'll leave this pool to be created and come back and look at it in the next lesson. So now that we've created our automated floating pool, let's move on to the next pool, which is an automated dedicated pool. This is a pool that we'll use for our purchasing agents. It will also be Composer based, and this time we will enable it for local mode. Now that we're back in View Administrator, we'll again click Add to create a new pool. Again, we're going to choose Automated Pool, so that View will take care of all the desktops for us. This time, though, we're going to choose a Dedicated User Assignment pool. Now, we do get one option with Dedicated that we don't get with Floating, which is the ability to enable automatic assignment. This tells View to automatically assign users to desktops if we haven't already defined that. To make the pool as automated as possible, we'll leave this enabled. We will choose View Composer so we have linked clone desktops, and our VCO1 server is already selected for us. Next, we'll provide an identification for our pool. We'll call this one Purchasers DT. For the display name, we'll use Purchasers Desktop. We'll use the default View folder and add a description. And then we'll click Next. We'll leave our pool enabled so that desktops are created after we're done. Since our purchasers will be accessing from both internally and externally, we're not going to restrict the connection servers at all. For the power policy, we'll set the power policy to power off. This will save resources when users are no longer using their desktops. Since these desktops will be dedicated to an individual, we don't gain a lot by automatically logging off the desktop. We'll give them a longer log-off period after they disconnect. We'll give them 8 hours after their disconnect before they're logged off. While this won't save us a lot of resources on the host, it will provide us the opportunity to more easily update the pools when the users are no longer using them. We're not going to allow these users to reset their desktops. Since the purchasers won't be doing a lot of installing of applications of their own or modifying the operating system outside of their own user profile, there isn't a lot of reason not to refresh their desktop, especially since refreshing the desktop will save us disk space on the SAN. So we'll set this to always. In conjunction with our automatic log-off after disconnect setting, this should force a refresh of the OS disk on a daily basis. We'll leave their default protocol as PC over IP, and also allow them to choose to override this. Our purchasers are generally going to be using laptop form factors for their client devices, so 2 monitors at a high resolution of 1920 by 1200 should be plenty for them. And for now, we'll leave the flash settings alone. These can always be tweaked later if we see issues with flash across the WAN. Now we'll move on to defining our View Composer disks. Since we selected a dedicated user assignment, we now get the option to define a persistent disk. We don't expect our purchasers to create a lot of data on their own, so their profile should stay relatively small, so a 2 gig persistent disk should be fine. And we'll leave it at the default drive letter of D, though we can change it to a different letter if we wanted to. The same goes for our disposable files. 4 gig should be plenty to handle our page file and the temporary files that the OS will create. Next, we'll move on to provisioning settings. We'll go with a similar naming pattern we used for the administrator's desktops. Since we have a well-defined number of purchasers, and each user will get dedicated a specific desktop, we don't need to oversize our pool. So we'll set our max to the number of purchasers we have, which is 4. We'll go ahead and leave 1 spare desktop powered on. Once all the purchasers have logged in, they'll all be assigned and there won't be any spares available anyway. And since we know how many purchasers we'll have, we'll go ahead and provision upfront all the desktops. Now you'll see a limitation that View has of the naming pattern, where we can only have 13 characters in the name. So we'll go in here and we'll cut this down. Now we'll set up our vCenter settings. Just as last time, we'll use the XP01 image. And use the base install snapshot. We'll use the vDesktops folder. We'll use our home cluster 01. We'll use our cluster resource pool. And we'll use our iSCSI and NFS storage both. We now have the option to choose a different data store for our OS disks and our View Composer persistent disks. One good reason to choose to separate these two is that we can place all the persistent disks onto a single data store, making backup of those persistent disks and the data they contain much more convenient. So I'll go ahead and choose the NFS data store to be our persistent disk storage. And since we only have two data stores to use here, we'll choose not to store the replica disks on a different data store, because if we did, we would get errors indicating that we don't have enough free disk space. And we can't double up two different disks. So we'll leave this disabled, and that'll allow us to continue. We'll choose the vDesktop's OU to store our computer accounts within Active Directory. And we'll use the default quick prep without any scripts. And then we'll click Finish, and the pool will create itself. Now let's switch over to vCenter and see our pool deploy. And here in vCenter we can see that a folder has already been created and clones are being made off the replica. This is because the replica has already been created when we did our administrative pool. So our purchasers pool has already been created and all 4 VMs have been deployed. View is now configuring the different disks and preparing each individual virtual desktop. We'll leave those to deploy and head back into our View Administrator. Now let's look at what the pool looks like within the View Administrator once it's deployed. First off, you'll notice that we need to entitle users and groups to this pool. We'll save that for a future lesson. For now, let's look at how the pool lays out in the View Administrator. On the Settings tab, you'll see all the settings we set when creating this pool. The Inventory tab will give us a good look at all of the desktops that are a part of this pool. Here you can see we have 4 different desktops created, which host they've been deployed on, and their current status, which is in the customizing phase. We'll talk more about that in a later lesson as well. The Sessions tab will show us what users are connected and more information about that session. The Entitlements tab will show who's entitled to access this desktop. The Tasks tab will show us work that's being done on the desktops. The Events tab will show us what events have occurred within this pool, once we have the event database configured. And finally, our Policies tab allows us to make policy changes to this pool. By default, these are all inherited values, but we do have the option of changing these on a per pool basis. So that's how you create an automated, dedicated pool within View Administrator. Next, let's move on to creating a pool for our IT administrators. Since our administrators tend to install a lot of their own software and need to have the software available to them time after time, we'll go with a manual dedicated pool. This allows us to create custom virtual machines for each user, import them into View, and assign a specific user to them. These desktops will not be affected by refreshes or recomposes, so we'll have to manage and update them the old-fashioned way, one by one. First, we'll start in the vSphere client. Here you'll see that we have 2 individual desktops created, one for John and one for Mark, who are both IT administrators. John needs his own specialized desktop because he runs a lot of memory-intense applications. So you can see we've given him 2 gigs of RAM. This is higher than our normal desktops have. Mark is also a unique use case. He does a lot of processing of data locally and creating of diagrams for the network and systems. So he actually has a higher than normal amount of disk space allocated to him. So these desktops have already been created and configured the way that these 2 users need them to be. Our job in View Administrator is to add these to a pool and explicitly assign each one to the individual users. So let's switch over to our View Administrator console. So now back in our View Administrator, looking at the Pools inventory, we'll click Add to create this new pool. This time around we're going to create a manual pool, which is a pool that we'll manage manually and not allow View to create, destroy, or manage the virtual machines. Our user assignment in this pool is going to be dedicated, so each user gets their own desktop. And this time around we're going to disable the automatic assignment. This is so that we can explicitly define who gets which desktop, which is important since there are different configurations. Next we choose what source our desktop is going to come from. We can either choose vCenter managed virtual machines or other sources, which can include physical computers or VMs and other hypervisors. Our VMs are obviously in vCenter, so we'll choose that option. Then we get to choose which vCenter is managing those VMs. We only have one choice here, so that choice is simple. Next we get to give an identification to our pool. We'll call this pool IT View. And for our display name, we'll call it IT Desktop. We'll leave it in the root folder and create a description. Now we'll click Next. Here we have the same set of pool settings we had for the other 2 pools we created. We'll leave this pool enabled. Create no connection server restrictions, because we want these IT administrators to be able to access their desktop both internally and externally. We'll take no power action on the remote desktop. If the user shuts it down, we trust that they shut it down for a reason. We never want to log them off after they disconnect, because IT administrators have a tendency to disconnect and move to another station on a regular basis. Since we trust our IT administrators to manage their own systems, we'll allow them to reset their desktops. We'll leave PC over IP as the default display protocol and allow the users to choose a different protocol. Since IT administrators tend to have a wide variety of displays, we'll go ahead and bump up the number of monitors and the max resolution to their maximum settings to support the wide variety that IT administrators may end up using. And we'll leave the Adobe Flash settings to their default, since we have no need to throttle them at all. After clicking Next, we get to choose which desktops will be a part of this pool. So we'll choose John and Mark's. And now we have all of our settings. So we'll go ahead and click Finish and let this pool get created. And now we have our new pool. Let's look at the details. So now let's check to see if our desktops have completely added to the pool by clicking on the Inventory tab. So now we'll see both John and Mark's desktops have been added and that their status is available. The only thing we have left to do is identify which user has access to which desktop. So we'll start with John's, and we'll select the Assign User task. This provides us with a typical Active Directory search window, where we'll search for John. Now we've found John, we'll select him and click OK. Since we have yet to entitle any users to this pool, View gives us a warning that this user that we're trying to assign access to this desktop does not actually have access to the pool. We'll go ahead and click this checkbox that gives us the ability to add a user entitlement. And now we'll click OK. Now back in the inventory view, we can see, after I expand this column, that the user John now has access to this particular desktop. Now let's do the same thing for Mark. We get the same warning about Mark because he has not been added as an entitled user yet as well. So we'll go ahead and let this wizard take care of that for us. Now both of our users have been assigned their specific desktops within this pool. And anytime John connects, he'll get John IT desktop. And anytime Mark connects, he'll get Mark IT desktop. So now let's switch to John's physical end client and show you what a connection to the View desktop looks like. We'll start by launching the View client. So once the client launches, we need to provide it the connection server we want it to connect to. And we can click Connect. It'll then ask us for a username and password. So here we're going to log in as John. View then provides us a list of desktops that user is entitled to, which we can see is the IT desktop. So we have the option of changing what kind of display we're going to use. If you're going to have more than one monitor, you want to make sure to choose multi-monitor. Otherwise, most users will end up using full screen. We also get some options per desktop pool here to choose from. We can choose Connect, which will immediately connect us to the desktop. We can also choose our display protocol, which we can see the default is PC over IP, but we do get the option to change it to Microsoft RDP. If we were already logged into this desktop, which we're not right now, we would have the option to log off. We also have the option to reset the desktop, since we enabled the end user the right to be able to do that. And since John happens to be using the VMware View client with local mode, he also has the ability to try and check out this desktop. For now, we're going to just decide to connect. Now John has his virtual desktop loaded. Looking at the configuration of this machine, we'll see that John actually has 2 gigs of RAM. And he also has a desktop that will never be refreshed or recomposed, so he can do whatever he wants to this desktop, including loading software. As administrators, we also have the ability to modify their virtual machines directly. So if John requires more RAM going forward, we'll be able to easily up the RAM by simply having him shut down and editing the properties of the VM. So while our ability to manage this desktop is diminished when using a manual desktop pool, the flexibility of the VM does increase, both for the administrator and for the end user. So that wraps up the last of our demonstrations on how to create pools in VMware View. So now a few extra pieces of reading for you. The first is the Performance Best Practices for VMware vSphere 4.1. These include items that will help increase the performance of your vSphere infrastructure. Next is the VMware View Administrator Guide, an invaluable document that I continue to reference over and over again because it's just that good. The View Optimization Guide for Windows 7 provides many of the tweaks and changes you can make to improve the performance of your desktops. This is one of just many guides that are available out there on the web. So do your due diligence and search out some of these other guides, and try to incorporate them into one of your own. Also talk to other people who have both managed desktops for a long time, those that have managed Citrix farms, and those that have done virtual desktop deployments already. Next are VMware guides for partition alignment. Here I give you two references. The first one is an old ESX3 document that is still very relevant to today, but still needs some updates, which is where I reference the second one, the Performance Best Practices for vSphere 4.1. This particular guide doesn't have nearly the detail of the ESX3 version of the document in regards to partition alignment, but there are some very important updates that need to be referenced. And finally is a knowledge base article that discusses partition alignment with View Composer disks. Essentially what it says is that as of View 4.5, the Composer disks that are created, the persistent and disposable disks, will be properly aligned when they're created. So to wrap up this lesson, let's review what we covered. First off, we talked about some of the best practices for our parent VM. We didn't dig deep into detail on this topic because there's a lot of stuff out there that you can do, and every environment truly is different and requires some consultation and consideration. Then we talked about the different types of View desktops and where you would use some of these types of desktops. These types included floating or dedicated, automated or manual, and linked and full clones. 3 different categories can be combined in any way. Then we talked about some of the configuration options that you can use when creating the pool. These include sizing options, power policy options, session management options like automatic logoff after disconnect or disconnect timeouts, and the location that the VM will be placed in both our vCenter infrastructure and our Active Directory domain. I talked about some of the underlying technology that make up linked clones, and discussed some of the special types of disks you can create when using a linked clone pool. And finally, we put these concepts to practice as we created 3 pools: an automated floating pool for our administrative staff, an automated dedicated pool for our purchasers, and a manual dedicated pool for our IT administrators who have very special configuration needs on their desktops. So thanks for spending this time with me. I'll see you in the next lesson.